Okay, ladies and gentlemen, I'm back. We're going to pick up where we left off. This is part 2 of the videos regarding AC analysis. And I was just starting off with this identity right here. And go down here where I have some space to draw. You can consider, let's see, e to the j alpha times e to the j beta. When you multiply these together, it's like, remember how exponents work? It's like adding the exponents. Equals e to the j alpha plus beta. Now, well, this equals cosine alpha plus j sine alpha. And this equals, and e to the j beta is cosine beta plus j sine beta. And this right here equals, and I'm going to go drop down to the next line, cosine alpha plus beta plus j sine alpha plus beta. We cross multiply this and this, and that becomes cosine alpha cosine beta minus sine alpha sine beta plus j cosine alpha. So this is first, this is last. First, remember FOIL, first inner outer last. First cosine alpha cosine beta, last sine alpha sine beta. J times j is a -1. That's this negative sign right here. Sine alpha cosine beta plus cosine alpha sine beta. There. So we can see, we can identify that sine alpha plus beta has to equal this per this trig identity. Cosine alpha plus beta has to equal that per this trig identity. We can see how we can derive our trig identities using this notation. People find it a lot easier, frankly. Once they get the hang of this, it's kind of like the metric system. Once you get used to it, people like it. Okay, moving on. I won't go through the rest. I do want to point out one thing though, and that is what happens when you change angles by pi over 2, by pi, or pi over 2. And it's these three formulas. You'll notice if we change the angle here, it just changes the sign. Negative sin of omega t plus pi is equal to the sine of omega t. Similar with the cosine. If you change by pi over 2, you get the cosine omega t equals sine of omega t plus pi over 2. Sine of omega t equals cosine of omega t minus pi over 2. So let's see how this works. We have two waves, and why does this lead by 45 degrees? If we write down the equation, the time has to be negative to make this equation true, to make this 0. So the argument is 0 at this point in this wave. So this wave leads. Stuff occurs on this wave before it occurs on this wave. It's leading. Now, we can also think of changing things by 360 degrees, because cosine omega t plus 45 minus 360 is cosine omega t plus 45. Cosine omega t plus 45 plus 360 is also equal to cosine omega t plus 45. Cosine omega t plus 45 plus 720 equals cosine omega t plus 45. I think you get the hang of it now. That we can say this wave starts 315 degrees behind this wave. So we're saying, okay, the difference in angle between here and here is 315 degrees. So when you say it leads by 45, it can also lag by 315. Here's a negative one. So in this case, you can think of this wave. You tell me. Pause for just a second. Think about it. What does this wave here, what does it lag or lead the first wave by? What's the phase angle? And does it lag or lead? Give you a second and pause. Let's go. So this is the negative sign, which shifts things by 180 degrees. Remember? Either plus or minus 180 degrees. So it either lags by 135, it starts, this point here starts, this point, the beginning, starts 35 degrees after this point. Lags. Or you can think of it as leading. So 360 minus 135 is 225. So way over here, we have the wave that starts out over here. This is negative 225 degrees. So it's leading. So it leads this. It's just wrapping your brain around this stuff. It's taking a bit long because we're just wrapping our brain around it. What do we mean by this stuff?